Okay, this is a video to get you ready for the Systems and Slopes quiz. This is about systems of objects, and that's when you have two or more objects interacting together. You have to analyze them and find things like tension and acceleration. So here we have a 5 kilogram box being pulled by a 10 kilogram box being pulled by a 50 Newton force. There's tension between the boxes, and in this case, the surface is frictionless. So you start off by doing free body diagrams of each object. So for the 5 kilogram box, the free body diagram would look like this. You have its weight, and we'll call that M1G. We'll call this box 1. We'll call this box 2. And you have, that's a better thickness. Okay, you have the normal force up, and you have tension to the right. For box 2, you have tension to the left. It's the same force. Tension within a string is constant. You don't have one tension at one end and one tension at the other. And to the right, you have a 50 Newton force, and you also have weight in 2G and the normal force. Now, the next step is to write what I call the sum of the forces equations, or the Newton's second law equation for each box. I'm not going to write the y equations because they're not relevant here. The normal force equals the weight, the normal force equals the weight, and there's no acceleration in the y direction. So the sum of the forces in the x direction on the first box, well, there's only one force. So that's tension equals ma, and the mass is m1a. And the sum of the forces on box 2, well, there are two. And the one to the right is positive and the one to the left is negative, so that's going to be our 50 Newton applied force minus tension equals M2A. And it's important to notice that they're connected, and so A for one of them is equal to A for the other. So A is the same value. In order to solve tension, we have to combine these equations. It's a system of equations. In this case, we can use substitution to solve them because I have T there and T equals M1A. So I can make a substitution of that for that. And so I get that 50 minus, instead of T, I'll put M1A. And that equals M2A. Move my acceleration term to the other side. So that'll be 50 equals M1A plus M2A. And if I pull that A out, that's M1 plus M2A. And so to solve, I just divide both sides by the sum of those masses. M1 plus M2, which is going to be 15. So I get acceleration is 50 newtons divided by 15 kilograms. And so the acceleration comes out to be 3.33 meters squared. And now I need to find the tension. Well, I can use either equation I want to find tension, but the one over here is easier. So now that I know the acceleration, I can simply say, let me get rid of this. I can say that tension equals M1 equals 5 times 3.33, that's 5 kilograms, 3.33 meters per second squared, and that comes out to be 16.7 newtons. So we have found acceleration, and we have found tension for the system of objects. So the steps are always the same. Your first step is drawing your free body diagrams. Your second step is writing the Newton's second law equation for each object. Your third step is then combining those equations, solving the system of equations. Sometimes it'll be substitution, sometimes we'll use another method. And then find the acceleration, and then plug stuff back in the tension. So those are your 5 steps. Next problem. We have, this is called an Atwood machine. We have two balls, or two, they don't have to be balls, two masses hung from a pulley. This pulley is frictionless and massless, or it gets way more complicated. And again, we're going to find acceleration, and then we're going to find the tension in the cord. So first step was free body diagrams. We're going to call this mass 1 and this mass 2. So for mass 1, the free body diagram will look like tension in upward and M1G downward, the weight of that object downward. For this object, it is tension upward and M2G downward. Now, signs, anything that would go clockwise is positive, and anything that would go counterclockwise is negative. So when we're writing our equations, the sum of the forces on the first object, it's got weight down. That weight would be a counterclockwise force, and it has tension up, which would be clockwise. So that tension is positive, and this weight is negative. So when we write the equation, we have P minus M1G equals M1A. And then the sum of the forces for the second object. Well, this is our positive thing because it's clockwise, and this is our negative thing because it's counterclockwise. So M2G minus T equals M2. Now, we're going to add these equations together because that's one of the ways we can solve a system of equations. And when we add them, we get T minus M1G plus M2G minus T equals M1A plus M2A. And we'll clean this up. Look, tensions cancel. That's an internal force, and it'll cancel when you put the equations together. And so, and I want a positive thing first. So I'm going to say M2G minus M1G equals M1 plus M2A. And I should have factored that G out already. M2 minus M1. Okay, to solve for A, we divide both sides by M1 plus M2. So my acceleration is G times the difference in the masses, M2 minus M1, divided by the sum of the masses. This is the general solution for an Atwood machine, and you would do well to remember that so that you don't have to derive it each time. But if you're solving this problem, you'll need to show your work. So now to solve for the acceleration in this particular problem, it's 9.8 times 10 kilograms minus 5 kilograms divided by 10 kilograms plus 5 kilograms, and I get acceleration equals 6.86 meters per second squared. Okay, so there's the first part of my answer, and now I need to go back and find the tension. I can plug things into either of these equations. I've chosen to use this one. So it's P minus M1 G equals M1A. Then T equals M1G plus M1A, which will be M1 is 5 times 9.8. Put your units in there, kilograms, meters per second squared, sorry, plus 5 kilograms times the acceleration, which is 6.86 meters per second squared, and I get 83.3 newtons for the tension. So the steps are the same. Three-body diagram, write your equations, solve. Three-body diagrams, write the equations, solve the equations, get your acceleration, and then plug it in and get your tension. Let's do this one more time. Kind of a combined problem, something hanging, something sliding on the table. And again, we're going to assume that it's frictionless. I should have put that in the problem, but it's frictionless. Three-body diagrams, our first step. We're going to call this object 1 and this object 2. So for object 1, we have M1G downward, and we have the normal force upward, and we're really not interested in that. And to the right, we have the tension. There'll be tension in this cord. For object 2, we have M2G acting downward and the tension acting upward. Sum of the forces on object 1. Tension is the only force, and so that equals M1A. The sum of forces on object 2, you have m2g minus t. And again, it's that clockwise thing. The m2g is our positive force because it would make this thing rotate in a clockwise fashion. And the tension is the negative force because it would make it rotate counterclockwise. And that equals m2a. Basically, your tensions have to have opposite signs in these equations. So make that happen. This is another simple one because we can just do a substitution. I can take m1a and substitute it in for tension in the second equation. So I have m2g minus tension, or m1a, equals m2a. Move my 2a things together, so m2g equals m1 plus m2a. I skipped a little algebra step there. When this comes over here, it'll be a plus m1a, and then I factored the a out. And so if I'm going to solve for acceleration, that's just m1 plus m2 divided by, nope, sorry, acceleration is, erase that quickly. Or not. Okay, sorry, okay, I was about to write it upside down. So a equals m2g divided by m1 plus m2. And if I plug values in, that is 10 kilograms times 9.8 meters per second squared, divided by the sum of those masses, which is 15 kilograms, and I get 6.53 meters per second squared for that problem. That's my acceleration. Okay, and now I have one tension. I could use either equation, but I think this is the simpler one on this side. So if T equals m1a, then T equals 5 kilograms times 6.53 meters per second squared, and that's 32.65 newtons. Make sure you put your units on all your answers. So the steps: free body diagrams, write your Newton's second law equations for each object, solve the system of equations, which is usually a substitution or maybe adding the equations together, find your acceleration, put your units on your answer, and then find your tension, put your units on your answer. I hope you found this video to be helpful as you prepare for your slopes and systems quiz.